Motion, speed, velocity, and acceleration. Should have something to write with. You take notes. Alright, describing motion. So, Newton's first law. An object at rest will remain at rest, and an object in motion will continue moving at constant velocity unless acted upon by a net force. So, unless a force is acted upon it, an object will stay sitting still, or will keep moving at the same constant velocity. Everyone good? So, motion. I have a question for y'all. Is your desk moving?
Yes. No. Yes. Yes.
So, if it's not moving, then how's the Earth going around the sun? It's staying still. How's the Earth rotating on its center axis? If it's stopped and if it's not moving, then shouldn't it just stay in the same point in space? So currently the Earth is rotating around the center axis. The Earth is going around the Sun. The Sun is going around the galaxy. And our galaxy is going through the universe. It is moving at quite a high speed or velocity. mind-boggling, like 10,000 miles per second.
Just imagine what would happen if we were to hit even such as much as a grain of sand.
It wouldn't do that much.
Exactly.
But we need a reference point. So everyone that said the desk wasn't moving, you were comparing it to the surface of Earth. Compared to the ground we're standing on, it is not moving relative to the ground. We need some non-moving point from which motion is measured. Motion is relative. So in order to describe motion, we need to have some reference point. Usually we will always say motion is relative to the ground. When we say something is moving, we're referring to to some stationary object. So we define a change in position in relation to a reference point. So here, if we let our reference point be the tree, we can see that the man is moving in relation to the tree. The tree is acting as a reference point, and we can describe the motion of the man as moving toward the right. So change in position in relation to a reference point is motion. That's another definition of motion, a change in position in relation to a reference point. Suppose that you are a passenger in a car stopped at a stop sign. Out of the corner of your eye, you notice a tree on the side of the road begins moving forward towards you. What's the problem here?
The tree is moving. Not supposed to do that.
Well, when you're driving on a car, the problem is you are mistakenly setting yourself as a reference point. If you're in a car, it appears as if the surrounding is moving and you're staying still. We usually do not set our own selves as reference points. We usually choose the ground or earth to be our reference point. So speed. Speed is the rate of motion. It is defined as the distance traveled per unit time. So speed is equal to distance divided by time. I believe y'all all told me y'all are familiar with the triangle. We'll get in here and define velocity in a second, but usually we let both speed and velocity be represented by the letter V. Speed and velocity are very, very similar. There's a key difference between speed and velocity that I will address later. But if you've seen the triangle before, you want to find speed or velocity, you cover up our circle V, and it'll give you d divided by t. If you want to find distance, you circle the distance in the triangle, and then you can read v and t are next to each other, so v distance is equal to velocity times time. Everyone good? Instantaneous speed is the speed at any given moment. It's like your speedometer in your car. Average speed is defined as the total distance divided by total time. So you can talk about the speed at which you travel from here to Lufkin. You can say that you traveled an average speed of 70 miles an hour. You figure out the total distance from here to Lufkin, divided by the total time it took you to get there. However, you didn't probably drive 70 miles an hour the entire trip. You probably slowed down to take the turn. You probably drove 55 on 1277, 75 on 103. Everyone good? You're alright, very slowly. You don't have to write the next one down, but here's a question for you. A storm is 10 kilometers away. It is moving at a speed of 60 kilometers per hour. Should you be worried?
Yes.
Yes.
Should you?
Well, it depends.
Depends on what?
Depends on where we're at.
It depends on direction. If it's moving 60 kilometers away from you, I wouldn't be worried. If it's moving 60 kilometers towards you, I would be very worried. It would hit you in about 10 minutes. So, this is the difference between speed and velocity. Again, I put the PowerPoints online. But velocity is speed in a given direction. So velocity includes speed and a direction. Note that you can be going 55 miles an hour in a circle. Your speed would be constant. It would be a constant 55 miles an hour, but your velocity would be changing because you are changing direction. So you can change your velocity by either changing your speed or your direction. So it can change even when speed is constant. That is the distinction between speed and velocity. For most part, I will treat velocity like speed, but you need to note that velocity also includes a direction. And if the direction changes, if you make a left-hand turn, you have changed your velocity. Does that make sense? Acceleration. Acceleration is the rate of change of velocity. So acceleration describes how much your speed or velocity is changing. It can either be a change in speed or a change in direction. So if you are making a circle, if you're going around in a circle, you are undergoing acceleration because your direction is changing. Or if you slam on your brakes, you are undergoing acceleration because your speed is changing. We'll learn later in the year that acceleration and force are connected. Whenever you make a left-hand turn, you can feel acceleration because it feels like you're being pushed toward the right. If you slam on the brakes, you can feel the acceleration as it feels like you're being pushed forward. So the equation, so it's the rate of change. So acceleration is equal to the change in velocity. That's VF minus VI over time. So VF is read as final velocity. You can also represent it as a triangle. So positive acceleration is speeding up, and negative acceleration is slowing down. You probably heard of deceleration. When you decelerate, usually we don't refer to it as deceleration in physics. We just call it negative acceleration. So, let's do an example. Your neighbor skates at a speed of 4 meters per second. You skate at 100 meters in 20 seconds. Who is faster, your neighbor or you?
You.
How fast do you move?
5 meters a second.
So even though you can do this problem in your head, it's better to work it completely out. On the homework, you'll be required to show all your work. It's best to identify the variables. So 100 meters is your distance, 20 seconds is your time, and you're solving for your speed or velocity. So solving for V, cover it up, and it's distance divided by time. So you take your distance divided by time, so that's 100 meters, divided by 20 seconds, and that gives you 5 meters per second. So you skate faster. 5 meters per second is faster than 4 meters per second. Jacob, can you quit talking? Everyone good? Y'all want me to go back? So a roller coaster starts down a hill at 10 meters per second. 3 seconds later, its speed is 32 meters per second. What is the roller coaster's acceleration? When doing these problems, we're going to identify the variables. So you look at all the numbers and figure out what variable they are associated with. So a roller coaster starts down the hill at 10 meters per second. 10 meters per second is the initial velocity, our initial speed. 3 seconds later, so 3 seconds is your time. Its speed is 32 meters per second. That's its final velocity, 32 meters per second. What is the roller coaster's acceleration? So that's the variable we're looking for. So we can draw our triangle, circle the A, and we see it's VF minus VI over T. Now we plug those numbers into the equation. 32 meters per second minus 10 meters per second is 22 meters per second, and we divide it by 3 seconds. We get an acceleration of 7.3 meters per second squared. So in this example, you'll notice that the units combine. A meter per second divided by a second is a meter per second squared. You'll also notice that this has basically 2 seconds in a meter. So an acceleration is going to have 2 time units and 1 distance unit. Whereas speed is in meters per second, it only has 1 second. So 1 time unit and a distance. So sound travels at 330 meters per second. If a lightning bolt strikes the ground 1 kilometer away from you, how long will it take for you to hear it? How many meters are in a kilometer? What does kilo stand for? What does kilo mean?
Kilometer or
But what does the prefix kilo stand for? It's the same thing as 1,000. So 1 kilometer, you can replace the word kilo with the word 1,000. So 1 kilometer or kilometer is equal to 1,000 meters. So we start with what we know. Sound travels at 330 meters per second. Meters per second tells us this number is a velocity or a speed. So our speed is 330 meters per second. If a lightning bolt strikes the ground 1 kilometer away, that tells you a distance. So distance is equal to 1 kilometer, and 1 kilometer is equal to 1,000 meters. Note that because velocity uses meters per second, our distance has to be in meters. And it's asking for how long is the time. So we're solving for time. So we can use our triangle, cover up the t, and we get that time is equal to distance divided by velocity, or distance divided by speed. So now we plug in our given variables. Time would be equal to 1,000 meters divided by 330 meters per second. The meters cancel out and the seconds are inverse, so we get 3.03 seconds. Does that make sense? Everyone good? So how long will it take a car traveling at 30 meters per second to come to a stop if its acceleration is negative 3 meters per second squared? So it says how long. How long is asking for time, so time is what we're trying to figure out. It says a car traveling at 30 meters per second. Well, that's its initial velocity. To come to a stop. To come to a stop means that its final velocity is going to be 0. And its acceleration is negative 3 meters per second squared. So we're trying to find time. So we would do the same thing, get a triangle, circle time, and we see time is equal to final velocity minus initial velocity divided by acceleration. So write out our equation, plug numbers into it, so we get 0 minus 30 divided by negative 3. The 0 minus 30 turns into negative 30. Negative 30 divided by negative 3 is 10 seconds. Any questions? Everyone good? This seem easy? This is what we're basically going to be doing the first 6 weeks. I will say you need to make sure you understand units. So distance. So distance units, we're going to be using the meters. Represent with an M. We might also use feet, miles. These are all units of distance measurements, distance units. Velocity, our speed, is going to be distance over time. So we could have a meter per second. That's a distance over a time. We could also have centimeters per year. That would be the velocity of a tree growing. Bless you. We could have miles per hour. So usually we write miles per hour like this. We have a distance and a time. An acceleration is velocity, change in velocity. So that's change in velocity over time. So it's going to have a velocity, which is a distance and a time, over another time. So we could have meters per second. So if you know math, that'd be equal to a meter divided by a second times a 1 divided by a second, which combines into meters per second squared. So instead of doing meter per second, we usually combine it as meters per second squared. We could have miles per hour per second. So we have one distance, one time, and another time. So we have 2 time units. We could have kilometers per hour per second. We could have also written this as kilometer divided by hour times second. These two are equal. You need to be able to look at a unit and be able to tell if it's velocity, distance, or acceleration. So if I say a car is going 5 meters per second squared, so a car is going 5 meters per second squared. This means the car is changing its speed at 5 meters per second is increasing its speed by 5 meters per second every second. Because this is acceleration. So is there any questions? If not, that's it for today.